Welcome back, Matadors. We're going to now be getting into Big Ideas Math, Chapter 2, Lesson 6 on perimeters and areas of similar figures. So now we have these two figures, they're similar. We're going to find out how their perimeters and areas are related to one another. So let's go ahead and begin with the essential question. So in red, how do changes in dimensions of similar, remember that's going to be the key word, similar geometric figures affect the perimeters and the areas of the figure. So just one thing to remember, when we're talking about perimeter, we're talking about a certain type of measurement. Okay, it's a one-dimensional measurement, right? It's one-dimensional. So that means that our units are just to the 1 power, right? They're just units if you measure them. Area is different. Area is how many dimensions? Right? It's 2 dimensions, right? It's a 2-dimensional measurement. So that means whenever you have your area, you have your units, but they're not to the 1. Now they're units what? They're units squared. So that's something to remember when we're going to be finding missing perimeters and areas of similar figures here. So please remember they're units. Okay, and how many dimensions are in each type of unit for each measurement. So moving on, the key idea in black, the key idea, perimeters of similar figures. When two figures are similar, so again, they have to be similar. When two figures are similar, the ratio, so remember a ratio is just a fraction, right, of their perimeters is equal to the ratio of their corresponding side lengths. So it's equal to the ratio of their corresponding side lengths. So in math words, the perimeter of the red triangle. Let's say you have a red triangle and you have a blue triangle. So the perimeter of the red triangle, that means if you were to add up all those sides there, its ratio would be equal to the same ratio of the corresponding side lengths of the red triangle and the blue triangle. So if you were to put the perimeter of the red over the blue triangle, its ratio would be the same as if you were to put side AB, the length of side AB, over its corresponding side DE in the other triangle. Okay? Or side BC over side EF, side EF. So if you were to use those numbers of the lengths of each side in a ratio, you would get the same ratio as if you were to put the perimeter of the red over the blue. And lastly, side length AC, so the number that would go there, over its corresponding side length of a similar triangle, DF. Okay? So you can set up, all those ratios should be the same when the figures are similar. Moving on. So let's find the ratio of the perimeters. We're going to use these two rectangles. We have a red rectangle and a blue rectangle. They are similar. Okay, they are similar. So we're telling you that these two rectangles are similar. So we're going to have to first set up a ratio, right? Set up a ratio. And to find the ratio that we're going to use to set up for their perimeters, we're going to use the corresponding side lengths. So we have two widths here. What we have provided to us are the widths, right, of both of those rectangles. So what is the width of the red rectangle? We'll go ahead and put that on top. It's 4. What is the width of the blue rectangle? It's 6. So now we have the ratio of the side lengths, or the widths, right, of our similar rectangles. But all you math whizzes know that this ratio, this fraction, can be simplified, right? Are you wrong if you leave it 4/6? No. But you can simplify it. I would prefer to deal with smaller numbers in math. And I'm a math teacher. I can imagine if I was in the 8th grade, I would also, too, want to keep my numbers as small as possible. So how can I reduce this fraction down? What do they have in common? They have a 2 in common, right? So I'm going to divide both of these by 2, and my ratio of their perimeters should be 4 divided by 2 is 2, 6 divided by 2 is 3, and this should be the ratio of the perimeters of the red and blue rectangles. So that means for every 2 values of red, you're going to have 3 values of blue, just like you see in their widths, right? In their widths, you have 4 and 6, and that holds the same ratio as 2 to 3. Moving on. So now, this is going to be our last example, or I'm sorry, I'm playing with you. This is our second to last example, but now we're going to be working with areas. So now we have 2 similar triangles, a red and a blue, and we're going to set up and find the ratio of their areas. Remember, area is measured in units. What do you do to those units? In this little pink box up here, what would I do to those units? Who can tell me that? Anybody? Okay, I'll tell you. It's units squared. Why? Because area, remember, area is a 2-dimensional measurement. So the first thing we're going to want to do, again, is we're going to want to set up our ratio. Now, the area of the red triangle over the area of the blue triangle has to start by using the corresponding side lengths that are given. So let's go ahead and write that ratio out. What is it? Well, it's just 6 over what? 6 over 10. Okay? And again, they're both even. I can shrink them down. So let's go ahead and do that. If I divide both numbers by 2, in its lowest form, in its most simplest form, I'm going to get a 3 over 5. So that's my ratio that I can use. Now, when I want to find the area, I'm going to have to do something to that 3 over 5. So I'm going to write in my 3 over 5 that I got from here, right? I got that from there. And now here's the one twist, because we're dealing with area, we want to find the area, the ratio of their areas. We need to do something, and there's my hint. We need to do something with these numbers. What do you think we have to do to them? What number do you think I should write up there? Square. We need to square them. So that means don't flip out because you're squaring a fraction. All you're doing, right? All you're doing to that fraction is you're applying that 2, that square, to both of those numbers. So on the top, I would have 3 squared, 9. On the bottom, 5 squared, 25. So that means the ratio of their areas is 9 to 25. That means for every 9 values in that area of the red, there's going to be 25 values in the area for the blue. Last example, I think. Let me double check. Yes. Last example. I don't want to get your hopes up again. So the 2 figures are similar. Find the ratios of their perimeters and their areas. The perimeters, you know, it's easy, right? You just take the corresponding side lengths, you set up your ratio, you're done. So let's go ahead and take care of that first. So we are given these 2 slant heights of these 2 parallelograms. And all we're going to do is set them up. Okay, looking on the bottom, right, we have the blue on top here and the red on the bottom. So we're going to go ahead and keep that same uniformity here. We're going to put let me erase the highlights. We're going to put the ratio of what goes on top, the 6, and on the bottom, 11. So this is the ratio that we're going to use, right? We're going to use that 6 over 11. Now, could that be reduced? No, it cannot. You're absolutely right. Thank you. So that means the 6 over 11 is going to be the ratio of their perimeters. So on the left-hand side, the perimeter of the blue, for every 6 that we get for the perimeter of the blue, we're going to get how many in the red? Well, we're going to get 11. Now, if I want to find the area, the ratio of the areas, what do I have to do to this ratio of 6 over 11? I have my 6, I have my 11. We're trying to find the ratio of their areas, so what do? I square that ratio. So that means, right, all that means is 6 squared over 11 squared. So 6 squared is 36, and 11 squared is 121, and you're done. So the key is when you have your corresponding side lengths, like you see here and here. Remember, perimeters, one-dimensional measurement, just put these numbers right into your ratio and you're done. Okay? When you're dealing with area, the difference is that you're using units squared, so you have to square the units that are given to you, the measurements that are given to you. Okay, if you have any questions, remember on Schoology, there is a class discussion. You can post questions that you have, specific ones, and I'll get to them in a review for a YouTube video. Okay, signing off. Take care. This is Mr. Science. Have a great day. Thank you for your time.